Good afternoon, everyone. My name is Christy Ford. I'm the account executive at Online Resources and your moderator for today. As a quick reminder, please turn on full screen mode for better viewing of the presentations. In addition, if you have any questions, go ahead and type those in as we go, and we will answer them at the end of the showcase today. We would like to welcome everyone to the deeper dive into Creaform's CubeR offline automated system with their very own VxScanR software. We have been a strategic partner with Creaform since 2006 and watched them grow into a global leader in 3D scanning technology over the past 15 years. We are excited to have them here with us today. Let's jump right in. Here with me from Online Resources is JD Schomburg. JD is the Director of Business Development. He's been with the company for the past 8 years and has been a part of 3D data collection for a total of 19 years. Thank you for being here with us today.
Thanks, Christy.
In addition, we have live from Creaform's Houston lab, Jared Schmidt. Jared is the National Sales Manager at Creaform. He's been involved with 3D CAD CAM since 1989 and will celebrate 10 years at Creaform in just a few days. Welcome, Jared.
Thank you. Glad to be here.
We're glad to have you. We have Emily Grenier here with us as well. Emily is the Regional Marketing Manager. She has been with Creaform since 2008 and has been in marketing for over the past 15 years. She has been involved in marketing for Creaform USA for the past 10 years. Emily oversees trade shows and webinars, as well as helps and supports the deployment and outreach of Creaform solutions across the Americas. Welcome.
Hi, guys.
And last but not least, we have Tyler Banta. He is Creaform's application engineer. Tyler has over 10 years as a mechanical design engineer in the aerospace industry, specifically designing high-precision multi-axis positioning systems. Creaform had the pleasure of welcoming him onto the team this past year. We are excited to have you here with us today, Tyler.
Thanks, Christy.
All right. Well, a warm welcome to everyone. Thank you all for being here. If we can start off, JD, with an introduction into Online Resources and what we do.
Sure. So again, I'm JD Schomburg with Online Resources. I am the Business Development Director, and we've been in business for about 30 years. We started, actually, this is our 30th year. We started in CAD CAM technologies and quickly decided that we had a skill set to identify technologies for manufacturing and basically qualify those for the industry. So we grew into 3D printing, 3D scanning in the late 1998. And then in 2006, found Creaform and developed along with them as a strategic partner. And so as we grew the scanning information and verified that for the industry, we also came along with the robotics side of things and have grown in that industry and have tested it, proven it out. And so that's why we wanted to join with Creaform today with their CubeR product and the VxScanR software systems, because we see this as a proven technology and the next step for Industry 4.0 for your offline inspection needs. So that's a little bit about Online Resources and how we got with Creaform today.
Awesome. Thank you, JD. All right, so if I can switch over here for just a minute to talk about Creaform. Do you want to give us just a little insight, and maybe Jared can jump in here and give us that introduction into Creaform and what you're all about?
Yeah, so Creaform, we'll be celebrating our 20th year next year. And Creaform came onto the scene with disruptive technology. So we were able to take scanning from the lab out to the shop floor, and that happened with the Handy Scan. And since then, we've developed MetraScan, the GoScan Spark, and now, of course, we have our CubeR. Again, this is a system that can operate in your manufacturing environment. As a matter of fact, I'm out here in a shop that's probably 90 degrees here in Houston at the Amatec office. So it doesn't need a controlled environment. You can have work trucks driving by and whatnot, because it works off the same principles as our other technology. You can see we have our C-Track up in the corner here. That C-Track is tracking targets that's on the MetraScan. And we also have some target pucks. I don't know if you can see them real well from that vantage point, but we have these target pucks on the fixture. So it's just a holding fixture that this Tahoe front end is on. And all that is tracked in real time, and they're put in the same reference. And this allows us to be immune to an environmental noise and vibration. So, so with that, I mean, that's pretty much what we have here. The flexibility in this system is going to be in the enclosure. So we can go with a chicken wire fence, or we can use a door or a light curtain. So, so yeah, with that, this is the neat thing about this system though is it's driven by an offline programming tool called VxScanR, and it can make you don't have to be a robotic expert to operate this software. So with that, I'd like to pass it over to Tyler.
All right, thanks, Jared. Let me switch over to my screen here. All right, so you get a part, you want to scan it. Rather than having to go in and manually jog every movement, VxScanR gives you the capabilities to not only do that, but be able to use your CAD reference to extract different surfaces or edges to create a scan. So why don't I just show you kind of how I would approach a part. The first thing you're going to do is import your reference part in your fixture, which I've already done here. You can also hide and show kind of all the different parts of your environment. So I'm going to leave the scanner and the robot visible just to be able to illustrate kind of what's going on. So with the VxScan software, you're able to essentially simulate your robotic environment. All of the commands that the program is sending to the robot is essentially sent to this digital twin of the robot itself. So you can run simulations pretty easily. So what we're going to do here is,
so Tyler has the advantage. Tyler has the advantage of sitting in an air-conditioned office and doing offline programming, while the CubeR can be running production parts. So
exactly. So we're going to add a surface feature for holes specifically. If you have a thin sheet metal feature, you want to get that perfect perpendicular 90-degree angle to the surface. That's a best practice in with all our scanning devices. So what like the software,
yeah, it looks like it's giving you, it looks like it's providing that perfect normal by default.
Yep. So it'll basically take your suggestion. You'll pick a surface and it will say, for this specific surface, we want to scan it at this, perpendicular angle. There are some instances which I'll illustrate later where you don't want a perfect angle because you're trying to get some interesting detail. So we'll go over a little bit of how to get those. For the time being, let's just create this here. And as you can see, we had these two different surfaces selected, but our merging value was set at a point where the two lines would make one scan. I can just show you exactly where that was right here. I'll try to get out of this dialog. So yeah, we've got this overshoot value, which helps when you have a scan and you want a little more information over here. You can increase that overshoot value, and that will get them to connect. So that's adding a feature using the edge or the surface feature type. So we can also do the same thing with edges. As you can see, anything that is recognized as an edge in your CAD model is capable of being selected. So for this area right here, we could come in and pick these surfaces or these edges. And then if you'll notice, we can have a localized adjustment. So you can change your normals angle. If you look at the side and notice your scanner is kind of coming in at a non-ideal angle, You can adjust that right there. If you want the whole line to move, you can adjust the normals angle on this side. So it gives you good flexibility. Kind of coming out of the full solution that it gives you and allowing you to change a couple things manually. So we'll create that right there. Very cool. And then let's go ahead and see what it gives us. So once we add a couple of features, essentially what's happening is we're telling it what features we want to scan. The program is then analyzing those features and deciding the actual path that the scanner is going to travel. This takes into account the reference model that you provide and prevents any collisions from happening. It will warn you if it thinks that there's a collision detected, and it will disable that scan sweep so you can go back in and modify it to get that data that you need. So we'll go over here and just do a reorder and finalize. So
this is when all the smarts come in, where the software picks the best speed based on the resolution, sets up your trajectories and put them the proper offset for the best scan, and does all of the collision avoidance.
Yep. So you've already defined each individual path. What it's going to do here is basically finalize them, lump them all together, and figure out the optimum path to go from each individual path to the next. So it optimizes your cycle time.
Excellent.
So once you have that, you can actually
digitally, like that we can do this in a virtual environment basically before we ever do anything. What a great safety feature.
Yeah,
exactly.
And still have the QBar out on the floor running parts. So this is taking, so Jared, am I understanding this correct, that this is basically the guy who would be holding the teach pendant is what we just calculated, that the path creation and all the safety and tool offsets, things like that. So that process is now pretty much removed through this VXCNR?
Yes. Yeah, and then I don't have to even know how to run a teach pendant to run this thing. So
Cool.
Yeah, and yeah, personally coming from a CAD background where I had a lot of experience with different CAD programs, it feels just the same as opening up, you know, your SolidWorks or your Inventor, and I kind of think of it as video gamifying it. It kind of takes the workout and lets you just focus on getting the details and you know, letting the software do the rest.
So can we actually simulate the path on this, or the scan on this?
So for metrology type parts especially, there's a lot of times where you're not concerned about getting the entire scan of the part. You only need certain key features. So you can come in here, add some scan trajectories where you think you're going to need them. And then it's really nice because you can play the sim and then it will show you the scan that you can expect to receive. So if you make a few scan trajectories, you can come in here, I'll hide my robot and my scanner, and then you can actually just do a show only selected of your scan. So you can come in here and kind of have a look at it and see what features you've missed. I like to go through and focus on the details of the part. And then once I know that I have good scan data in those areas, I can come back at the end and just get a more general broad scan.
Okay, so this looks like it's a really cool feature, and I'm going to question here and clarify.
Sure.
Did the QBar actually run and scan this, or is this a digital STL from the CAD for planning purposes?
This is a digital STL from the CAD for planning purposes. So
that's cool.
You could take this model and plug it into your inspection report and basically verify that you, again, have information where you need it. So
can we finalize this and shoot it over to like VX Inspector Polyworks?
Sure, we can do that. While I'm here, let me just show you just real quick. So we have the surface and the edge feature, but we can also add manual trajectory. So the way you can do that is just adding these lines here.
Here's picking points.
Yep, you can pick points. So you get a little more manual control as opposed to the manual or the surface or the edge. But then if you want full, I just want to tell the robot what to do, you can open up the jog feature, and I'll just show the robot in the scanner to give you a better idea. So you can click on the part and it will turn the turntable and position the robot so that it will be able to scan that position. I'll make that visible as well. So then once you're in here, all you have to do is add a point. You can jog it wherever you want, add another point. Maybe you wanted to go this way, add that point.
It looks like it's projecting the scan, the lasers onto the part to show you your optimal offset distance.
Yeah,
am I right?
And this is really helpful because you can move it in and out and figure out how deep you can get to get certain features.
Wow.
Sometimes you can, there's some strange areas you got to get into, so you can position it basically any way that you want to.
This is cool because this
so
almost
that's really
feels
helpful.
like you're using an industrial as a collaborative.
Yeah, exactly.
That's cool.
Right, but you don't have to actually grab the robot. You can just do it virtually.
Yeah.
That's pretty slick.
Oh, cool. So why don't we just take this, and you have the option also to send it to Polyworks. I'm just going to send it over to VX Inspect just to give you an idea of what this will look like. Since this is essentially a scan of the perfect part, the color map is actually going to look pretty good. But this will give you the idea of what you can expect to look at.
Well, but this helps you prepare your inspection plan too. So
sure.
So it doesn't matter if the data is if it gives you a perfect part. So.
And I really like just how clean this interface is. If you have the Creaform software, so I'm used to the VX Elements interface, this just makes sense. Over on the left side, you have your standard tree that you use and just a very clean, easy interface. So congratulations on that, because this is taking the difficulty for me in the robotics environment and making it pretty easy to see.
Sure. And then once we add VX Inspect in, like you said, it just pops up in the same navigation tree. So this again gives us a pretty good part. We're all in the green. You can add annotations for different
surface points, true position, call outs, whatever. Yep. So you get your full inspection. Awesome.
Just out of curiosity, can I see the holes? Because I know that's something we had talked about. I know that's something that's a big deal when we're looking into the manufacturing environment. Can I see those in this virtual environment here?
So come over here. You show. Oh, actually, I reset the sim. We're gonna have to run this again real quick. See it appear in thin air in front of you, since I have everything shown. So this is showing just what the scanner is picking up, as you can see. I can lock my viewpoint and actually have a look at it while it's scanning. So from the top down here,
wow.
And I believe this is in a 1mm resolution, so I can even refine that. Yep, there we go. When you do that, it will change the scanner to a slower speed because you want more detail. So it will go slower over those areas. Make sure it gathers enough data.
And that does that automatically?
Yep.
Wow.
It's almost making life too easy over here. It's the good old days when we got out there and got dirty, I'm missing that much.
I'm sure you're enjoying the air conditioning more than I'm enjoying the heat.
I'm surviving in here.
Yeah. Who suggested Houston? No, I'm just kidding.
Well, while we're waiting for this, speaking of Houston, can you tell us a little bit about this Houston lab?
Yeah, so we're sharing space with another Amatec division in the Houston office. It's right off the Sam Houston tollway on the near Katy, I guess, a little north of Katy, Texas. So we've got commercial space here. We've got a couple account managers working from here, ISS, internal sales, marketing folks, and then we've now got 3 application engineers working out of this office as well. So it gives us, because we have the Irvine office, which we've had for several years, but it makes it easier for us to get to the east side of the country without having to spend a full day on a plane. So, so this has been a great space for us, and having the capacity to drop our Q-bar in here. The Q-bar footprint, by the way, is about 13 by 13. Unless you go with the light curtain, it's a little bit longer for the safety restrictions of the light curtain. And you can also put in your own protection system as well. And a couple other options on the Q-bar is the turntable. So you can go with different capacities. I think it's 500 kilogram or 1,500 kilogram weight capacity. So.
Wow.
But yeah, so this has been good for us to have this office here.
That's really cool. With this Q-bar, this is kind of a standardized product. So I'm assuming that because it's that way, it can then be deployed to multiple locations with an exact, I guess, CAD run. What do you call that?
Well, yeah. So the Q-bar is a standard product. So it's the same product if you buy it in Mexico or Germany or Italy or China or Japan. So, and it makes the deployment easier for international companies. So they're not having to work with different integration partners across the globe. They can work directly with Creaform or our reseller partners there, because we're all supplying the same product. So
excellent. And so in theory, maybe it's not in theory, in actuality, you could have somebody programming in the US and
Yep.
sending that program out to your satellite systems in other countries.
yes.
That's cool.
Yep. Yeah, and they just have to do an alignment adjustment to make sure that where they said the part was virtually, it is physically on the turntable. That's really it.
Okay.
It's part of our software too. So, yeah. So I think we could take a closer look and I guess Tyler's still rescanning those holes with a better resolution.
So I can just pause it there and we can have a look at it real quick.
Okay.
There you go.
Nice.
So, and that's a good illustration of, it's nice. You can go through and look at those features, and you can tell right off the bat, my resolution's not high enough, my scan speed's too fast, and go back in here and just custom tailor it to each individual part. And then once you have the scan profile set for a part, you can just, load a new part into the cube, hit the button, and see where it lands.
So this has all been done digitally so far. Can we see the thing actually run?
Yeah.
Sure. So once we're done with this, we actually have a scan profile already set up out of the cube. We don't have our network drives here logged or set up in Houston, so we don't have that easy step, but the file sharing is extremely easy.
But
Cool.
yeah, it's okay. I mean, we've got a full program already set for this. So
so all you got to do is click connect to robot, and then you're able to send your scan trajectories and profile to the cube. We'll send it on out there.
So Jared, are you there? I don't see you on the screen.
Oh, I have to click a button. Sorry about that.
You're good.
Okay, so I think I'm here now, right?
Yep, there you are.
Okay, excellent. So we'll show you some of the features of the system here. So what's nice too, we've got the floor protection systems in there. So if you're inside and you try to close the door, it won't close the door. If you close the door and stop it from close, you can just stick your arm in, it'll stop from closing. It's hard to see, and I don't have a good setup with the camera, but we have a pneumatic connector on the Metra scan that will grab the calibration bar that's seated in the back. And we also have a calibration plate that can be pulled out, so you can run an automatic calibration each day, or as needed. Whoops, I'm out of the way. So it's quite nice for that. So we've got the automatic calibration. We've got the automatic photogrammetry, which is another thing. So those pucks that you see on there, instead of having to shoot that fixture with a photogrammetry system separately, we can just load it in and rotate it and capture the positioning targets on the fixture. So that's a real fast process as compared to systems that have to use a manual photogrammetry system to capture that.
I really like that, Jared, that automatic photogrammetry. I know that's been added also to the manual system in a setting, which I played with a little bit. But you also get that dynamic tracking from that photogrammetry shoot, correct?
Absolutely.
So,
yep. And that's why we can certify our accuracy. It's 17025 certified in a lab, and it's VDI VDE 2634 Part 3 certified as well. So,
very cool.
And it does, like I said, doesn't matter where it sits in your environment. It could be, sitting next to a press that's operating or a machine that's running. Fork trucks can drive by. It doesn't matter. You're not going to lose your accuracy. So, and it looks like Tyler's got this started running. So this is probably as good a time as any to take some questions from our audience.
Yes, great idea, Jed. So I remind everyone to send your question through the question tab of your GoToWebinar panel, and then we will take some time to answer them. So I'm going to start with the first one that we have. I think this one might be for Tyler. How long does it take to learn how to use this system? Oh, Tyler?
Yeah, I mean, it's going to be different for everybody, but it's, like I said, I've got quite a bit of background in CAD. I've done a lot of trainings with people who don't have a lot of background in CAD. Once you learn the basic controls and the interface, it's extremely user-friendly. You can kind of fumble your way through it the first day, and by the next day you'll be extremely proficient at it. It's, like I said, I mean, you've seen how user-friendly it is. You're able to use your CAD model directly as a reference.
So for
me, real quick,
we
prescribe a 3-day training session for it. So
okay, so for me, I have a little bit of fear playing with a robot. I'm not used to robots. I'm not super comfortable with them. But from what it sounds like with this collision avoidance implementation and all of that, it's hard to do something wrong on this system.
Exactly.
Okay.
Yes. Yep. And we also have an option for asset protection where we can actually store the configuration of a fixture, meaning the target configuration. So that way, if someone loads the wrong fixture and tells it to use a different program, we will protect the user from running that wrong program with the wrong fixture.
Very cool. Yeah, I like that.
I think I said that right. But we're just using the targets to identify it, which makes it really easy. So
all I heard was I can't mess it up.
Exactly.
You're correct. Okay, then talking about questions, I have another one here, and it's maybe a question in 2 parts. So I have questions about the maximum size of the parts to get measured, and what happens if my parts are bigger than that or too big to fit in a cube. So JD, you want to take one? Oh,
go ahead. Well, I'll answer the size. So the part size for this is about 10 foot wide and about I think it's about 10 feet high. So obviously you're probably pushing the envelope and doing a lot of turntable moves with the single, with that single robot. But if it goes beyond that, I'll let JD answer. So.
Sure. So I think this is where it probably comes into more of our strength, which is a custom type of system. So the QBAR is utilizing the Metriscan R, which
Right.
the QBAR is a full package of that with the, I believe that's the FANUC. I don't know what.
Yeah, it's the FANUC M20 IA, I think. Yep.
So it's using that industrial arm where some of these custom applications that we use are either inline systems where they need that cycle time, 100% of the parts, they don't want anybody touching it, automatic feed, automatic in and out with a yes, no signal. It can go to that kind of level, or for the size, you might need a gantry custom gantry that would go all along the side. So let's say you have a 10-meter part or 30 feet. How do you do that with one system? So I think that's where the custom application comes into play with some of the control systems that we have. So our robotic software is robot agnostic. So if your specs call for a collaborative, we can do that for you.
Right.
But I still think this VxScanR application of the Cube, that's slick.
Right. So I mean, this is where a partnership with like Online Resources is really essential for Creaform, in that we've got a product here, but it's really an offline or at-line system. I mean, we know it can just run in your shop, but you're not going to feed it with a conveyor. It's not meant for running hundreds of production parts a day. It has to be hand loaded or fork loaded, and this is where JD and the folks at Online Resources can take our Metriscan R, our C-Track, and our tracking technology and put it into a completely custom solution to run at to run your production parts, to run inline, to communicate with other systems. So yeah. So I think that was a long answer to a short question, but
I think we covered it. Yes, I think we're good to go to the next one. So I have a few questions about the accuracy of the QBAR. Maybe Tyler, you can give us an answer.
I think Tyler lost connection, but that's okay. So so the accuracy of the QBAR is it's 25 micron accuracy of the Metriscan. The volumetric accuracy, worst case, is 78 micron. So it is, as I said before, it's 17025. It's built in a 17025 certified lab. We're VDI and VDE certified, the 2634 Part 3 certification. So you can trust our accuracy. I know there's a lot of videos out there showing the accuracy of the handheld Metriscan and the handheld HandyScan, and we tend to, all of the repeatability tests I've done, we're repeating at half our spec. So
yeah, and I can speak to that. That's one of the reasons we've identified Creaform as one of our strongest 3D scanning partners, is because when they spec something, it is absolutely going to meet that spec. And I think I've done an unboxing video of the HandyScan Black where I did a 24-inch ball bar and got 5 microns difference distance, and that was repeatable. And so I'm not comfortable speccing that all the time, but when you're talking about a spec of 9/10 of a thou, or about 20, 25 microns, and we get 5, I mean that's the trust
right.
that I have in Creaform, in that when they put something out there, they've done their work in proving it out.
Right.
I still test it myself, but
it's okay. It's fun to do. So.
Good. I got another one about does the system or is the system able to detect vibration? How does it work? And do we need to compensate, or do you compensate for it?
Right. So the system doesn't have to detect vibration. So what it does is that C-Track system that you see in the upper corner here, that's optically tracking the scanner head and the fixture or the part that's targeted. It's locking them into the same reference. So this could literally be floating on a raft while it's scanning, and it wouldn't care. So it just doesn't matter. It's not impacted by vibration, so we don't have to have vibration sensors and things like that that would stop it from scanning if vibrations got to be too bad.
Good.
So,
And you mentioned it before, but temperature is not an issue because it's pretty hot in the Houston lab, right?
yeah, I can attest to that. I don't know if you can see the sweat on my forehead yet, but
Thank you, Jared.
right.
And we've actually, for the temperatures, we did our own temperature test and taking the system well up over 100, I think it was 115 to 120 degrees, and then tested the accuracies. So when I say we test the systems, we push them to their limits of what we think is going to be the most extreme environment our customers will be using these systems, and make sure that we still can quantify that spec that Creaform gave us. And I called Jared. I mean, I've never had to, but I would call Jared if I didn't see the spec numbers come out.
Good. And I think we still have time for one more question, but I have a question about how can I integrate a Q-bar in my production line? You want to take this one, JD?
I guess I'll take that one. That's more of an
Yeah.
inline system.
Right.
And that is where we'd like to use our robotic control software. So we go through a lot of questions that would come up. What kind of system is feeding it? Things like that. I'll use a quick high-level example of an application that we had where it was a roto-mold customer where one mold dumped a few parts onto a conveyor, and we never knew if those parts came out ABC or CBA or what order they were in. And they just came down the line, and we were able to identify the part, identify the path, put those together, and then scan or do the appropriate movement with that. So that's where our custom software that we partner with QPoint on comes into play and makes that possible.
Right.
Good, thank you. Yeah, and maybe, well, I got a last one, so I think, Christy, we still have time for another one?
We've definitely got more time. Go ahead.
Good. I have a question about, can we get help with our first parts?
For sure. So we can assist or give you direction on fixture design. So because targeting is sometimes a new concept for people, or the optical targeting. So we also can supply some of these. I mean, this puck I showed earlier it's a nice rigid metal surface that'll hold up. So we can provide those pucks. We can provide the design assistance, and then we can also help with even programming in PolyWorks or VX Inspect those initial parts to make sure that things are going well. And we can also deploy application engineers like Tyler to make sure your initial runs run smoothly, that your operators understand how to operate the system, because you're going to have people who are probably going to be creating the programs, and then people who have to run the system, and it's easier to have that assistant, or it's easier to implement when you have that assistance on site. So
I have a question. This is a pretty big part in there.
yes.
Do you have a different setup for a smaller part or an even larger part than this? Because it looks like it's pretty medium sized to what you were saying, the 10-foot part. So I'm just trying to figure out, does this,
Sure.
the Q bar itself adjust according to the part size and that kind of thing?
Well, I mean, you load your part in your virtual environment. You could have, if you had small parts, you could have 5 or 10 on a fixture, for instance. So, and if you have a larger part, you would know in the virtual environment if you can actually accomplish scanning the whole thing. So, and that's where I really like the tools in there, because you've got simple tools like the surface and edge selection, and then the manual pick points. But you can also jog the robot into a position to see if you can reach those hard to reach areas. So, so the software makes it simple to evaluate quickly. And if you think of, manually jogging this with a pendant a teach pendant, for instance, yeah. it would probably be, I mean, it could be a day, maybe a little more to make sure because you have to pick your positions, you'll have to be constantly adjusting if the offsets aren't good or the speed isn't right and whatever. And being able to sit down in the software, you can probably program this thing in about an hour and a half, so it's quite special. And then getting that digital feedback. I mean, I think you saw what Tyler did, where he scanned the holes. It wasn't good enough resolution. He changed the resolution, rescanned them, and yep, looks good. Now he knows he doesn't have to. He's not wasting a lot of time out here validating his path. So.
Yeah, I love that. Okay, great. Thank you for that information. I appreciate it. Do we have any more questions, Emily?
Not for now.
Okay. Well, I appreciate everyone for joining us. I want to thank JD and Christy at Online Resources for including us in your automation series. You guys are doing some really cool stuff, and we're just glad to be a part of it. So thank you.
Well, thank you guys for being here. We really appreciate you coming and showing off the Q-Bar with us today, and for your time and efforts and presentation. That was really helpful. A lot of great information there.
I guess I have one question. If someone's interested, how do they get started with this? Like, that's a question I get a lot. We want to do automation. Now what?
Right.
So how does someone get in contact with you and start going down this AQC route?
Yeah, I mean, they can. Our website is definitely a great tool for requesting more information. They can certainly contact you guys directly as well. So, but yeah, it's creaform3d.com, and it's on the brochure that's in the attachment to the webinar. So. And then you guys are onlineresourcesinc.com, I believe, if I got that right.
Yep.
So yeah, they can get a hold of us this way.
Yeah, awesome. Thank you, thank you. That is our showcase for today. We've enjoyed this time here today.
There's a monster spider running around in here.
Oh.
I caught it out of the corner of my eye. I thought it was a mouse. So. Just waiting for it to crawl up my leg. Anyway, I'll let you go.
If your question did not get answered, or you have any other questions, please do not hesitate to contact us. As Jared said, you're welcome to do that at creaform3d.com or at onlineresourcesinc.com. You can email us directly at support@onlineresourcesinc.com. or call us directly at 765-482-9700. I just wanted to say one more time, thank you again to everyone who participated, and thank you to all of you for joining us today in this webinar series, and we appreciate everyone's time and hope to see you again soon. Have a great day.
Excellent. Thank you.